What we're going to look at today is 4 key definitions. And if you learn these 4 key definitions, you're happy, okay? It will carry you through the rest of this year, especially if you choose to do Year 11 and Year 12 chemistry, it will help you out there as well. So, before we get into these definitions, let's talk about what a compound is. So, all of the above compounds, so the things that we were writing the formulas to yesterday and last night, are known as ionic compounds. And this is because they are formed from the attraction between positive and negative ions. Now, when we're talking about this, I'm going to annotate these notes slightly. The positive ion, does anyone remember from Year 9, what is always the positive ion?
The metal.
The metal. So above this one, we can write this is the metal. And over to the side with our negative, this is always the non-metal. Now, this is the case for all ionic compounds. Ionic compounds are made up of a metal and a non-metal. Okay? So, the name of the ionic compound comes from the 2 parts that make it up. So it's always, again, metal followed by non-metal. But there is another type of compound. And I'm going to use a separate colour. And this other type of compound is what shares electrons and has a different name. Okay? So these other types of compounds that share electrons instead of transfer them are called covalent molecules. So what we're going to do down the bottom of your page here right now. Over on the left, I'm going to write the word ionic. Over on the right, I'm going to write the word covalent. When it comes to the left-hand side of the page and we're talking about ionic bonds, they are between a positive and negative ion. They are between a metal and a non-metal. So, ionic. We're doing 2 bullet points for each. This is metal plus non-metal. And when we talk about the electrons, it doesn't state it explicitly in this paragraph, but there is one key word that I want you to mention. It is that electrons are transferred. Okay, so I'm going to write transfer electrons here. And I'll talk about what that means more in a moment. So transfer electrons. When it comes to our covalent molecules, on the other hand, so what I've highlighted in green in the paragraph, 2 key dot points again. The first dot point is that covalent bonds only occur between non-metals. So it is a non-metal plus another non-metal. Now, I've highlighted it in the paragraph. What happens to the electrons in green in a covalent molecule, covalent compound? Great, okay. So, share electrons. So, the reason I note these 2 things in particular, they're the really important parts about identifying ionic versus covalent. Okay? So, if you see a metal in the compound, you're going to think that is ionic. If you don't see a metal in the compound, you're going to think it's covalent. And it also tells us what happens with our electrons. So let's jump in to look at some examples of some different covalent molecules. Okay? So these are all covalent because they are missing what from their formula? What do none of them have in their formula? Covalent is non-metal and non-metal. So what are we missing in all of these covalent molecules? A metal. There's no metal, right? So if we look at our first example, it's already done for you. We have water. The formula for water, I'll get to it in 2 seconds, is H2O. And H2O, if we were to break it down, 1 molecule of water, or H2O, consists of 2 atoms of hydrogen joined to 1 atom of oxygen. So what I'm going to have you do right now is I would like you to fill in the rest of this table. So what the formula means. Hopefully, you're familiar with CO2 and what CO2 stands for. We'll go through the answers in a minute, but for now, give it a go. Methane gas. 1 molecule of methane consists of what?
1 carbon atom and 4 hydrogen.
Good. 1 carbon atom. What's the linking statement? What's the word that I want to use to link them?
Join.
Great. Join to 4 hydrogen what? Good. Now, The reason I'm being particular on this and not just saying, hi, can you please just write 1 carbon plus 4 hydrogen, okay? The reason I don't want that, you're not practicing using scientific language and you're not practicing putting it into a sentence. Now you're probably thinking, when do I ever have to do that? The answer is your test, okay? Now, if I ask you to put something into a sentence or to follow the example that I've given you, generally speaking, there is a good reason for it. And today, we will be doing a few more written questions before we get to balancing. And for these written questions, I promise you it is important that you practice writing. I know it's chemistry, but please practice it. Question?
Are we studying balancing today?
We are, yes. So, our next one. After ammonia, I'm not going to fill these two in for now, but what was CO2? Great, carbon dioxide. So, here's what we're going to do. There are some really common covalent molecules that we need to know, and we need to know their names and their formulas. So, you have water pre-drawn for you. How many hydrogens are in water? 2. Great, H2. And how many oxygens are there? 1. So we go H2O. Next one, okay? If we look up here, we had water. Our next one was methane. So I'm going to draw a line down the bottom left again. And the formula for methane was CH4. Do you need to know these ones? Yes, please. Okay. These are sort of non-negotiables that you should know at this stage. When we talk about CH4, how many carbons are there in CH4? 1. So I'm going to draw a big carbon in the middle here. And how many hydrogens are bound to this carbon? 4. So I'm going to draw 1, 2, 3, 4 hydrogens spread evenly around that carbon. Do you need to know the structure? No. But this is just more to help you visualize and see that 1 carbon is bound to 4 hydrogens. Okay. So our next one after methane was ammonium. Okay. And ammonium is NH4. Okay. Did we give you ammonium or ammonia? Sorry. Oh, sorry. Ammonia. Okay. So when we're talking about ammonia, ammonia is NH3. Now we're going to start in the middle again with our nitrogen. And this is bound to 3 hydrogens. So I'm going to spread these hydrogens around nice and evenly. So H, H, H. Our final one, CO2. We're going to draw our carbon in the middle, okay? And how many oxygens is it bound to? 2. So we're going to draw 2 oxygens over on the side like that. So this is CO2. So what do we know? We've already stated this on our page above, but covalent molecules are formed by joining what and non-metals together? Is it metals? It's non-metals. So covalent is by joining non-metal and non-metal together. And what happens is they exist as separate molecules. So in the water molecule, so in this one up the top here, I'll highlight it in yellow. In the water molecule, the hydrogens are permanently attached to the oxygen. Okay? And what they do is they exist without bonding to the other oxygens around it. Okay? So these to the other water molecules around it. So these water molecules can exist as H2O here, H2O here, H2O here. And how do we see water most of the time? It's in the form of a liquid. Okay? So all of these H2O molecules are right next to one another, but they're not bound together. Okay? They're next to one another, but not bound. So let's talk about some really important definitions. I said that there were going to be 4. These are the 4, and then we're quite literally almost done with this lesson. Okay, so number 1, an atom. This is the easiest definition, but I would also argue it is the most important. So the atom is the building block of everything. Okay, what is the smallest unit of living things? Starts with C. That would be hilarious if caterpillars were the smallest unit of all things, but yes, it is cells, okay? So, cells. Atoms are bigger or smaller than cells? Smaller, okay? Atoms are much, 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 much smaller than cells. And so the examples that we've got here, you can have a gold atom. You could have a carbon atom. It is just one of that atom. You could have a hydrogen atom. Okay? Next is our definition for the word molecule. And a molecule, to be clear, is when two or more atoms are joined together. So in this case, we can have water. Water is what? What was the formula for water? We just did it. H2O. So how many atoms do I have in H2O? How many atoms do I have in H2O? 3. Okay. We have 2 hydrogen atoms and 1 oxygen atom. So how many altogether? 3. What about over in oxygen gas over on the right-hand side? Oxygen gas is just O2. So how many atoms do I have in oxygen gas? 2. Good. Now, following on from molecules, we can have things known as an element. And an element, there's a really important part to it, is what we call I'm going to underline it, I would suggest you do the same, a pure substance. And if something is pure, it means that it is only made up of that type of atom. So, if you got a gold ring, do you want it to be a pure gold ring? Hopefully, okay, worth a lot of money. And that pure gold ring is only made up of gold atoms. So we can see that this one here, this gold, is made up of 12 gold atoms stuck together. On the right, we can see that this element, oxygen gas, is made up of 2 oxygen atoms stuck together. Now, these elements, okay, gold and oxygen, are they also molecules? Are they 2 or more atoms joined together? Is gold 2 or more atoms joined together? Yes, there's 12 atoms, so it is both an element and a molecule. This is a lattice, yeah, but it is a lattice made up of 12 gold atoms stuck together. When we talk about oxygen gas, it is 2 oxygens bound together. Is this 2 or more atoms bound together? Yes. So these examples are both an element and a molecule. Okay. Now, here's the most important one. Compound. When we talk about a compound, it is something that is made up of 2 or more different. And I can't underline that word different more. Okay? 2 different atoms. So when we're looking at water here, we said water was H2O. What are the 2 different atoms that we have? Hydrogen and oxygen. How many atoms are there altogether in water though? 3. When we talk about carbon dioxide, what are the different atoms in carbon dioxide? Great, carbon and 2 oxygens. And our final example was methane. What was the formula for methane again? Great, CH4. So a compound is made up of 2 or more different kinds of atoms. So if we scroll back up here, okay, I've got my molecules. Which of these is a compound? One of them is a compound. Which one is it?
Water.
Water. Why is water also a compound? Excellent, because it is made up of both hydrogen and oxygen. Oxygen gas, on the other hand, is a molecule, but it's also what instead? Also a element, because it is a pure substance. Okay, so that's it. Okay, that's this part of the lesson completely finished. That's it done. What you need to know is those 4 words. Question?
Does that mean a molecule can be an element or a compound? So
Correct.
Or a compound is just a version of a molecule?
Correct. Yeah. So you can think of a molecule as like an umbrella term, and you've got element and compound sat underneath. Question? Sure. Right, so let's fill in this last little table together and then we're done here. So, ionic, it is made up of what? What is ionic compounds made up of?
Metal and non-metal.
Metal and non-metal. When we talk about covalent, what we've just been looking at, it is made up of Excellent. Non-metal and non-metal.
Is there anything that's metal and metal?
Yes, they're called metallic bonds instead. We talk about them later on. Okay. So when we're talking about electrons, when it comes to ionic molecules, okay, these ones are lost and gained. Okay? And the word that we used earlier was we used the word transferred. Okay? The second word, when it comes to covalent molecules, we said that they play a little bit nicer together and that they share their electrons. So the electrons in covalent molecules are shared. Now, here's our important definition. Do ionic molecules or do ionic compounds form molecules? And the answer is going to be no. And I'm going to clarify one thing here. What they instead form is what we call a lattice. Okay? They form a lattice. So form a lattice. So what I want you to think of, an example of an ionic compound is something that we call NaCl. NaCl is sodium chloride, affectionately known as your everyday table salt. Okay? When I say something has formed a lattice, I mean that it has formed a crystalline structure or a crystal. So has everyone seen those like big ocean or sea salt flakes that you can get, or the big, maybe you've got the salt grinder at home and the salt grinder has those bigger pieces of salt? They are the crystals of salt. They are the lattice. Okay? They are what form in an ionic compound. On the other hand, when we talk about covalent molecules exist. So we can say yes in this box. Do they form molecules? Yes.